Good afternoon, everybody, or good early morning to some of you in the other continents. My name is Soria Petran, and I will co-lead this session, which is the third session of Panel 8, together with Kurt Emil Eriksen from Velux. The topic for today is how to accelerate the route to climate neutral building stock. And we have a very fine lineup of speakers. I will start with Hanna Westling, who is consultant in sustainable energy systems and sustainable cities at Anthesis, Sweden. Then we will have Melissa Zill from Environmental Coalition on Standard, ECOS. She's a project program manager at ECOS. Then we will continue with Youssef Boussa from Linnaeus University, also in Sweden, the Faculty of Technology, Department of Built Environment and Energy Technology. And then we will have two dear friends of mine from Romania, Mariu Șoflete from Creative Engineering, structural engineer, a passive house designer and trainer, an online content creator, quite active in Romania, raising the awareness on the market on passive house and nearly zero energy buildings, and also a hot passivist, I would say. And Dragoș Arnautu from Passive House Institute in Darmstadt, senior energy consultant and trainer. So just a brief presentation of the plan that we have today is very simple. We have all the presentations pre-recorded. So we will play it one by one for the around 15 minutes. And then we will have 5 minutes of question and answer. You can write your questions at any time in the Whova section of question and answers. I will translate them in Zoom because we are in Zoom here. So we will present to the panelists and we will try to answer in a discussion after each presentation. And then hopefully we will have like 10 minutes discussion, an overall discussion, unanswered questions and whatever at the end. So this is the plan. This is the fine ladies and gentlemen in the panel. And yeah, Kurt, if you want to add something.
No, you did it perfectly again. I think we should start the presentations.
You're so kind. Yes, we will start with the first presentation. So I will invite Hanna Westling to present practically the identification of the business model for energy renovation of the single family houses for the Swedish market. It is called Accelerating the Energy Efficiency Renovation of Single Family Houses.
Hi everyone, my name is Hanna Westling and I'm working as a consultant in energy and sustainable cities at the Global Sustainability Consultancy Anthesis Group. And Anthesis is the sustainability activator, and together with colleagues in 17 countries, we in Sweden work with cities, companies and other organizations to drive sustainable performance. And together I will present the paper Accelerating the Energy Efficiency Renovation of Single Family Houses, which I've written together with my colleague Agneta Persson. I'll start by introducing BESMO, and BESMO is a network aiming to improve the energy performance in both existing and new single-family houses in Sweden. The network is initiated by the Swedish Energy Agency, and it is co-financed between the Energy Agency and the member organizations of the network. Anthesis, with myself and two colleagues, are coordinating the network on behalf of the Swedish Energy Agency. And the aim of the network is to contribute to the transition to a sustainable energy system by accelerating the realization of energy efficiency measures in existing single-family houses and to push energy performance in new single-family houses. And this paper is based on a feasibility study which Anthesis has conducted within the network as well. To some background, In 2019, a feasibility study was carried out within Besmo on the energy efficiency potential of single-family houses in Sweden. This study showed that there is a large share of profitable potential for energy efficiency in existing single-family homes, and that the energy demand in the single-family house sector could be halved with profitable measures. And even though such a large energy efficiency potential is profitable, several studies show that only a small part of the measures are actually being realized. In addition to this large potential, there are several initiatives that aim to increase the pace of energy renovation. The EU renovation wave aims to double the pace of renovation over the next 10 years, and the EU regulation on a taxonomy for environmentally sustainable activities creates a classification system for sustainable economic activities. In addition to these initiatives from the EU, there are ongoing activities in Sweden, which includes, among other things, of course, training initiatives on sustainability and energy efficiency for contractors and installers in the construction sector, and research and business based on one-stop shop. The feasibility study, which this paper is based on, has aimed to identify business models for large-scale, cost-effective renovation of existing single-family houses in Sweden. The business models aim to include the identification of single-family houses where it's beneficial to implement packages of energy efficiency measures. And the aim has also been to make it easier for individual house owners to implement relevant measures that contribute to reduced energy demand in the single-family house sector. The methodology. The feasibility study has been conducted through the following 5 steps, with the identification and analysis of similar initiatives, identification of stakeholders and key players, development of packages with measures for energy renovation, and collaboration with ongoing projects and initiatives, and recommendations for business models and continued work. And most of the work was carried out as interview studies and dialogue meetings with stakeholders. This study has focused on identifying areas with homogeneous single-family houses. The chosen approach is mainly based on national statistics on the Swedish stock of single-family houses, but other possible methods include digital maps, dialogue, thermography, energy performance certificates, and the chosen method, which is statistics. The study has been limited to single-family houses built between 1961 and 1981, and this delimitation has been chosen as numerous houses from this period are relatively uniformly built. From a national point of view, these houses also account for more than a third of all Swedish single-family houses, and therefore a large share of the energy demand of the single-family house stock. The houses have also reached an age where there is likely to be a need for renovation. With the help of the Statistics Sweden's database called Masterfile, areas with the homogeneous single-family houses have been identified. And with the help of this database, it's been possible to locate these areas and characterize the houses in the areas. Implementation of multiple energy efficiency measures in combination has been identified as a key to cost-efficient energy renovation. And 3 categories of single-family houses have been proposed for this application, and the categories have been based on common attributes for the houses in Masterfile. And they are the 1.5-story house, and the single-story house, and the 2-story house. And common for all of these 3 are electrical heating, concrete-based foundation on the ground, double-glazed windows, and natural ventilation was dominant in the single-family house sector until the mid-1970s. And these 3 categories in total make up 70% of the houses in the identified areas in single-family houses. By using the database, master file and chosen criteria resulted in 5,655 areas with at least 25 similar single-family houses in each area. And the areas together contain almost 300,000 single-family houses. And where the areas are located can be seen on the map to the left. If a larger number of houses in a single area is sought after, there are, for example, 460 areas in Sweden with more than 100 similar single-family houses in each area. The suggested packages of energy efficiency measures have been named zero energy, near zero, conversion to a liquid-borne heating distribution system, and indoor climate focus. The package for zero energy responds to long-term climate ambitions, and the package for near zero answers to the criterion in the EU taxonomy on a 30% reduction of the primary energy demand. Conversion to a liquid-borne heating distribution system has been developed due to the increasing demand for electricity to reduce the climate impact from other sectors. And to the last one, a large share of the single-family houses in Sweden are not sufficiently ventilated, and the last package has been developed as a response to that. The combination of measures and the ambition of the zero energy package can be seen on this slide, with the goal being to reach zero energy demand on a yearly basis, and the measures included can be seen here. Stakeholder dialogue has been crucial already at this feasibility stage to prepare for future projects. And several obstacles for realizing the energy efficiency potential has been identified both from the house owner's perspective and from the perspective of entrepreneurs. And the joint procurement in energy efficiency renovation can likely contribute to increasing the interest of more contractors providing energy efficiency measures to single family house owners and make it easier for the house owners as well. Experience from the stakeholder discussions shows that it is difficult to identify an individual stakeholder who is prepared to take on the overall responsibility and coordinate practical offer to how there is consent, that clarity and simplicity are important factors for everyone involved. And for the vast majority of single family house owners, it is probably important to have a coordinated actor. Difficulties for and cost efficiency is important for both the individual house owners to carry out energy renovation on a larger scale, but it is also important that other stakeholders find the business model profitable for them. The study has shown that there are several ways to accelerate the pace of renovation in Swedish single-family houses through packages of energy efficiency measures and services for energy renovation. And actors for project on different scales, and they can be seen here. And I can add that there are no clear answer as to which actor should take the overall responsibility, and that all of these levels from an area level to a national level are possible routes to accelerate the renovation rate. Efficient use of energy in buildings is important for achieving the national as well as international goals for energy and climate. An efficient use of energy in buildings is also important due to the enabler to the sector. And the four packages for energy efficient renovation can enable a fast transition of the single family house stock in Sweden. And this is cost-efficient potential for energy efficiency measures. It should also be noted that additional single-family houses are built each year, but the existing buildings will continue to make up the majority of the houses in the stock. And it is therefore important to not only focus on building new energy efficient houses, but to also increase the efficiency of the existing house stock. The study has been conducted to create ideas and business models which can increase the rate of energy efficient interventions in single family houses in Sweden, and packages of measures provided by one actor or a combination of actors have been found as a solution to increase this rate. And this business model can help overcome some of the obstacles to realize the energy efficiency potential. But the study provides indications that these models may need support from the EU, from the national government, to gain real momentum and realize this energy efficiency potential that exists in the Swedish single-family house sector. The discussions held with market actors conclude that designing and implementing a pilot project is a natural next step to test some of the proposed solutions. Although it will be important to adjust design depending on the actors involved and the chosen level of a test area. And at the same time, as a pilot project is being implemented, the design of a strategy for upscaling should be further investigated. And this further investigation of upscaling is necessary to understand how and which actors can take the business models from tests at individual locations to include large part of the Swedish single-family house stock. And other benefits of energy efficiency are likely needed to be showcased, since the large potential of cost-effective energy efficiency measures is not being implemented. And therefore, visualization and marketing should be prioritized in the continued work. Thank you.
Kurt Eriksen here. I think it was a very interesting presentation. I cannot start my video, so I will be without video, but I have a few questions. I think you point out some very good challenges that we have in the sector. And I think it's also very interesting that you're going to do this pilot project. Can you elaborate a little bit more on the pilot projects that you are thinking about, specifically if you will work with pilot projects for all 4 areas, zero carbon or zero energy, near zero conversion, and indoor climate focus? Will you make pilot projects for each of them, or will you only make a pilot project for one of them?
Thank you. We have not decided on that yet, but we are having discussions with different actors who may be interested in participating in a pilot project. And depending on which actors who choose to go forward with this will affect which of the packages we continue with.
Thanks.
I like very much the fact that you focused on the market, you focused on collaboration, which is crucial in the implementation of renovation, and emphasizing multiple benefits. It's also crucial. I would have a question. If you think that the energy or the building renovation passport could be part of a sustainable business model for the renovation for the Swedish market?
Probably yes. We have been thinking about I wouldn't call it a passport, but some way to make sure that the measures that are conducted are being like transferred if a new person buys the single family house. So to make sure that they know what has been done to the house before and so on. And even if people forget what has been done or want to improve something over time.
Thank you. Another question from the attendees. Important to emphasize multiple benefits. This is one of the conclusions. Are you referring not just financial, but comfort and specifically health? For the warm, stable environment with controlled humidity, air quality, and how this affect things such as blood pressure, illness, or early mortality due to excess winter death? Are these included in the multiple benefits?
Not in this study. I should mention that we have conducted another study within the network of Besmov about multiple benefits. And in that study, we looked at the model from the International Energy Agency and tried to come up with what a model for the Swedish part and especially for single family houses should look like. So we have that model in mind. What we have been thinking about here is that we need to find people who are not always thinking about energy efficiency first. We want this business model to aim and to a lot of the single family house owners, and then we need to be better with telling them about the multiple benefits, because some people may care about the energy efficiency, some people care more about climate, other people care more about what their neighbors are doing or about the indoor climate. So we want to make sure to show all of these multiple benefits to increase the rate of energy efficiency.
I agree. And here is an urgent question. Given the urgency of the renovation of our buildings, is not too late to run a pilot project? Can Sweden just include this segment in its long-term renovation strategy or national recovery and resilience plan and just get on with it?
We are seeing policies for multifamily houses and for energy efficiency packages aiming towards that part of the building stock, but it is hard since we have about 2 million single family houses in Sweden with a population of about 10 million people. And there are a lot of people who need to be addressed when it comes to this sector. So we are having conversations with the Swedish Energy Agency as well, but we are seeing that a pilot project might be a good way to test this business model and make sure that the relevant actors are being included.
Wouldn't it be better to also be involved in the consultations for the implementation of the long-term strategy, for example, for the resilience and recovery plan?
We are having ongoing conversations with the Swedish Energy Agency, yes.
Okay. Thank you very much.
Thank you.
I don't see any other questions, so I think we can jump into the next presentation. The presentation will be given by Melissa Zil from ECOS. She will talk about available scenarios that investigate the possible changes in the heating sector by 2030. And the title is quite catching, The European Heating System at a Tipping Point.
Good afternoon. Welcome to this session discussing the future of the European heating system. My name is Melissa Zil. I'm a program manager at ECOS. We are an environmental NGO based in Brussels, active in the field of standardization and eco-design and energy labeling, among other things. We co-authored this paper together with Edouard Toulouse, who's an independent consultant working on efficiency and sufficiency, with Davide Sabadin, who's working at the European Environmental Bureau, Green NGO based in Brussels as well, and Gunnar Ollesen from the International Network for Sustainable Energy based in Denmark. So in this paper entitled The European Heating System at a Tipping Point, we have tried to reply to three main questions. So what does the decarbonization and greenhouse gas reduction objectives mean for the building sector? That's the first question. The second question is, what do the various energy scenarios for the sector say? And the third question is, what needs to change in the current policies covering buildings and especially heating equipment? What needs to evolve for those policies to meet the decarbonization objectives? So on the methodology for this work, we've used the desk research and analysis of different sources, and also our own experience based on our work on policymaking in Brussels. So the main source is the impact assessment study made by the European Commission in 2020 to support the 55% objectives of emission reduction by 2030. But we've also looked at the preparatory studies to set energy efficiency regulations for space and water heaters. This one is from 2019. And then we've also used a number of publications from non-governmental stakeholders, such as BPIE or ECOS or EEB. You have the links on the slides. A little bit of context at this stage. You're probably familiar then with this emission reduction target that we've been talking about to reduce greenhouse gases emissions by 55% in 2030 compared to the 1990 levels, and to also reach climate neutrality by 2050. These are both objectives that the von der Leyen Commission sets itself in the Green Deal policies. For the building sector, what does it mean? It means that from emitting 440 million tons in 2018, the sector will need to reduce its emission by 42% to reach 255 million tons in 2030. This will be a challenge, and especially because of most of these emissions come from the heating sector. As you can see on the graph on the right-hand side of the slides here, residential and non-residential space and water heating make up for most of the final energy consumption in buildings in Europe. And the problem is for this heating comes still from fossil fuel, which means that in 2015, residential space and water heating emitted as much CO2 as the entire EU car fleet, so 500 million tons. So the building sector needs to achieve large emission savings, actually larger than any other sector, and so the Commission has analyzed the scenarios that could support this reduction of emissions in its impact assessment study that I mentioned in the methodology section. And there you can see that there are different types of scenarios with different energy mix for the heating sector in that impact assessment study. But basically, to achieve the 2030 targets, oil and coal for heating will need to be nearly fully banned. And the natural gas consumption for heating will need to be reduced by 40%. And this is a big challenge because the majority of the heating appliances in the EU, installed in the EU, are gas boilers at this stage. And one thing that's clear from all the scenarios presented in the impact assessment study is that the key factor to reduce the emissions will be a fuel switch, meaning replacing the fossil fuel boilers by other alternatives. And this fuel switch will have to be actually quite intense to reach the objectives. In our paper, we've then discussed the different options to meet this challenge. One of them is cutting the heating demand. So this would need to be done by increasing the renovation rate for buildings by 10 to 15 compared to the current speed, so quite a big increase. And this would bring a 25% cut in the final energy demand for heating and cooling by 2030. But it's a very ambitious objective. Second option is to aggressively promote cleaner technologies for heating, such as heat pumps or solar thermal, but not to rely on for example, hydrogen to be a silver bullet to just replace the natural gas in the pipes that is currently used in most of the buildings. So really promoting cleaner technologies and not business as usual, relying on a last minute silver bullet, such as hydrogen. And a third option to meet this challenge would be to put an end to the sales of new fossil fuel fired heating technologies. This is not just us who say that, since paper, and actually what they say is that we should ban the new sales of fossil fuel boilers by 2025 to meet net zero. So we've looked at the different options to reach the 55% target, but what would it look like in concrete terms for the policies, especially on heating system? This is what we are going to see now. First, this means that we urgently need to stop subsidizing fossil fuel heating technologies, even gas. This is not the case yet, as you can see on this map on this slide. This is an analysis made by our colleagues at EEB, which shows that most of the EU countries still incentivize fossil fuel heating. So we need to urgently stop that. Second, we need a much higher ambition in the eco-design and energy labeling regulations for heating appliances. So these policies, you might not be familiar with. They are often underlooked in the climate discussions, but they can be very powerful, as we shown in the beginning. Since they've been introduced for space and water heaters, they've actually helped cutting 80 million tons of CO2. So how does it work? On the one hand, Ecodesign removes the least efficient appliances from the market, and energy labeling pushes consumers towards the most efficient appliances. So they work together. And the problem we have now with these regulations is they have been introduced in 2013. At the time, they made a big change because they pushed for more condensing gas boilers, for example, but they are no longer adapted to the climate objectives, and they are in need for a significant revision now to meet the climate objectives by 2030. So this revision is ongoing now, and actually there are two main aspects that they could target to help reach the objectives, which are changing the energy label first, because currently it still offers a big push for gas boilers, actually, which, well, the gas boilers now, they have an A+ or they can have an A+ or an A rating on the energy label scale, and this could potentially not be changed until 2030. This is set in the energy labeling framework regulations. Actually, heating appliances have a special derogation for what we call the rescaling, which is going from a scale going from A++ to D back to an A to G class. So we call for a change of this energy label as soon as possible, and we've proposed actually another scale with A to G classes, where the fossil boilers would be in the lower classes, so in the F and G classes, whereas the top classes would be composed mostly of the most efficient heat pumps or hybrid technologies. So that's a first thing we need to see happening on the eco-design and energy labeling policies. And then actually we think that eco-design regulations could be used to phase out the fossil fuel boilers from the market. How? By setting a minimum efficiency threshold for space heaters mostly, which would be set at 105 or 110%. And this would de facto phase out from the market the appliances working mostly on fossil fuels. So we would still keep on the market some of the hybrid appliances. And this is not This idea actually is not that revolutionary, because many of EU and non-EU countries, they already have plans to ban certain types of appliances, such as well, oil or gas, depending on the countries in new or old buildings, as you can see here in an analysis from the Eco Institute. So indeed, there's we need urgently to look at these eco-design policies and to finally have them meet with and be coherent with the wider climate targets, which they are not for the moment. And these policies, the revision of these policies, should be discussed in September this year. What would it mean for the natural gas consumption if we would ban gas boilers? Well, you see on this slide that from the consumption in 2015, it would anyway be reduced by 25% by 2030 if we don't ban gas boilers. Why? Because of a reduction of the heating demand, and because the appliances on the market are supposed or are expected to improve by this time. But if we would ban gas boilers in 2025, then we would manage to reduce the gas consumption due to gas boilers by 42% by 2030, thus making it easier to reach the climate targets. So in conclusion, maybe a few points on the limitations and general reflections on this topic. First of all, we are wondering whether decision makers and stakeholders really understand what the targets, the climate targets, would mean for the building sector, and also what would it mean to cut the use of natural gas by 40%, because it means very ambitious policies on mainly heating appliances. So are policymakers ready to make the changes in policy happen to cut natural gas by 40%? This remains to be seen. There are massive technical and financial barriers to progress on deep renovation and the fuel switch needed to achieve the targets. So, and this needs to happen in the short term. So we need to stop installing basically fossil fuel heating right now if we want the emission reduction objectives to be met. And this can be perhaps overly optimistic given the time that remains between 2021 and 2030. And the current policies are not fit for purpose regarding this new objective, especially for Ecodesign energy labeling. The revision is ongoing, but it's slow. Last time these regulations have been adopted, the discussions went on for 7 years, but this time we are hoping that they can be concluded in September, and that actually the revision will prove us wrong, and that indeed the policies will be adapted for the climate targets. So that's it on the presentation. We will now discuss some questions, I suppose, with the co-authors of the paper. Thank you very much for your attention.
Thank you. It was a very good presentation, I think, and it was very interesting that that we need to switch to other boilers, and I think that your solution to set an efficiency level on 110% is very good, because then you would shortly squeeze out not that energy efficient boilers, fossil boilers. But what about the existing building stock? I mean, if I understand your presentation correctly, you are focusing on installing new boilers. It's about the new boiler. How have you been thinking about the option to have people to motivate people to replace their old boilers and install new, better boilers? Have you thought about those things, and have you any solutions to that?
Yes, thank you. So about the installed stock, yes, indeed, it is old and inefficient, and the replacement rate is really low. In this paper directly, we haven't really touched upon that, but the effort to have people change their heating systems in their installed heating system. There are several projects. For example, in Germany, there is a mandatory labeling of the existing heating appliances. So whenever a technician comes to check your boiler, they have to give you an indication of where that boiler is on the energy label. And so then you perhaps realize that you have something very inefficient in your house, and you perhaps proactively change it. So that's the first. Then as ECOS, we are also a member of Horizon 2020 project, doing exactly the same thing, promoting labeling of installed appliances through a web app that's on the project website. And then people can get an energy label for their installed appliances, and also solutions of what would fit their house for a replacement solution. But yes, it's a big challenge.
And then I think I would also like to mention, that your presentation was updated, because you had a slide from the new IEA report, which clearly states that we need to ban boilers, not efficient boilers, from 2025. But the report also tells a lot of other things, interesting things, and it is among others that we also need to increase the renovation rate dramatically, and you also showed that. But I didn't understand the 10% to the 15%, because normally we talk about an energy renovation rate around 1%, and you certainly talk about 10 to 15%. Are there anything there which I can't get those figures to work? We do not renovate 10% of the building stock.
Yeah, it's not a percentage. Maybe I wasn't clear enough. It's going from a percentage currently of 0.2% per year of buildings that are renovated to 2 to 3% per year. And this is from a paper from the BPI, the Buildings Performance Institute. So yes, so that's the first. That's the point.
Yeah.
And of course, yes, you didn't. I mean, you noticed that we used the graph from the EIA report. For us, it was a big push on the right direction. The publication of that report was very good news, because we are also trying to influence the EU policy in that sense. So indeed, indeed, we added that to the report. But what they say is that we should stop selling new boilers. So stop putting them on the market, because the problem is that they will last then 20 to 25 years. Mm-hmm. And in 20 to 25 years, we are almost in 2050. So how can we be climate neutral by that time if we still have so many gas boilers installed in the next 10 years? Mm-hmm. Gas, mm-hmm. Oil and coal, of course.
And if you allow me, or if everyone allows me, I can only recommend people to read that report from IEA, because there's a lot of good information on the building stock. So it's extremely relevant for eceee also to discuss this. Yeah. I don't know if you have any comments, Horia.
Yeah, I'm having a comment on the ban of fuel boilers. I think, yes, it's good to have this, and the manufacturer of boiler or gas boilers will make some sort of a roadmap if they know what is the policy and what is announced. But I don't think it's enough to have the sticks. You have also to have some carrots. Because, for example, if you want to replace the gas boiler, you might not replace with an efficient boiler or another fuel, but maybe you will have a heat pump. And in many countries, I would say the case of Romania, electricity is almost 4 times more expensive than the gas. And I experienced the replacement of a gas boiler. I installed last year a heat pump, an electric one. And I paid almost the same as I paid before, but only because I had a moderately renovated home with a heat recovery, ventilation, mechanical ventilation, and I increase the air tightness. So you have to have some stimulation, some incentives to offer, not only to go to the stick, in my opinion.
Yes, yes, that's very clear. One thing also is that we could expect the price of gas to increase and the price of electricity to decrease in the meantime. So then at some point, if we want to reduce the amount of gas in the energy system by so much that we meet our targets, something will have to be done. And yes, and probably about the price of gas, something will have to be done. So that's a first lever. Of course, we should not let down the poorest consumers, which there will be a lot of issues with energy poverty if all of a sudden people are stuck with gas boilers and very, very expensive gas. But indeed, yes, the subsidies should go towards funding more cleaner alternatives for everyone. Indeed, yes.
Yeah. Thank you. I'm not very happy to end this discussion here, but maybe we'll have some minutes at the end of the session, because we have to jump to the other presentation. So back to Sweden. Yusuf Busa will present, in fact, the effect of carbon taxes implementation on the cost-effective renovation of multi-apartment buildings in Sweden.
Hello and welcome to this presentation. I'm a PhD student at Linnaeus University and my name is Yusuf Busa, and my main supervisor is Ambrose Dodo and Trong Nguyen and Katarina Rupergal. And today I will talk about the topic of energy efficiency measures integrated to the thermal envelope of a multi-apartment building located in Sweden, where we analyze the cost effectiveness with respect to carbon abatement costs implementation. As it is known that the increased use of fossil fuels in the energy production is the main contributor to the rise of the average temperature of the Earth. And if we look at the different sectors, we see that the building sector accounts for approximately 40% of the global primary energy use. As a result, European nations have set many strategies and policies to improve the performance of the buildings. And one important policy is that all newly built buildings should be nearly zero energy buildings by 2050. And if we look at the buildings in Europe, we can see that approximately 70% of the building stock still exist in 2050. As a result, it is important to renovate the existing buildings as well. And if we look at Sweden, and as it is a member of the EU countries, the Swedish government have also set targets to reduce the energy use in buildings. And one main target is that the energy use in buildings is to be reduced by 50% in 2050 compared to the energy use levels in 1995. And if we look at the building sector in Sweden, we can see that the most buildings are residential, either multi-family apartment buildings or single-family houses. If we look at the multi-apartment buildings, we see that most of them were built in the 1960s under the so-called Million Program, which was launched to overcome the shortage of housing at that time. And at the moment, most of these multi-apartment buildings which were built under this program are in need of renovation due to material deterioration and poor indoor quality. And if we look deeply at the energy use of these buildings, we can see that approximately 55.5% goes to the space and hot water heating. Hence, the aim of this study is to analyze the effects of involving the CO2 abatement costs on the cost effectiveness of the energy efficiency measures which we integrate to a multi-apartment building located in Sweden. And to achieve the aim, we analyzed the final or the influence of this final energy heat savings on the fuel inputs in a district heating production unit. And we looked at it from a wider European energy system perspective. Our case study building in this analysis is a multi-apartment building, which is located in Växjö, southern Sweden. It was built under the Million Program in 1965, and it consists of 12 apartments and 3 stories. The total heated floor area is approximately 1,200 meters square, and the total ventilated volume is approximately 3,200 meter cube. And the methods we followed in this analysis is that the first we determine the final energy savings from the implementation of these energy efficiency measures. And this is by the means of simulation using Ecodesign. And afterwards, we perform a cost effectiveness analysis on the applied energy efficiency measures. And then we estimated the amount of biofuels to be saved by reducing the final energy use. And we assumed that this CO2 or this biofuel saved is used to generate a clean electricity, which then will reduce the CO2 emissions. And this CO2 emissions we assumed from the saved biofuel. And afterwards, we implement the carbon cost abatement costs, and to see the influence on the cost effectiveness of these measures. As we can see, the initial building envelope, we have the U values for windows, doors, attic floor, and ground floor, and exterior walls. And we can see that most of these U values are relatively high, which results in high heat losses through the building envelope. And to the right, we have a picture of the building. And as we can see, the facades of this building are in poor condition due to material deterioration. And when we simulate the initial energy use for this building, we can see that the higher specific energy use goes to the space heating with approximately 103.7 kilowatt hour per meter square. And as a result, the main step we choose or we seen to be followed is that we improve the building envelope elements, and we choose glass wool insulation to improve to the attic, exterior walls, and ground floor. And we assume different range of thicknesses from 50 to 500 millimeter. And we analyze different U values from 0.18 to 1.8 watt per meter square Kelvin, where the doors we used from 1.1 to 1.2 watt per meter square Kelvin. The approach followed to estimate the realized benefits from carbon abatement costs, or from implementation of carbon abatement, is to look at it from an overall energy system perspective. And when we apply these energy efficiency measures to the multi-apartment building, we reduce the demand, final energy demand, and hence we reduce the amount of biofuel that we use in the district heating. So this reserved or this reduced amount, the remained amount of biofuel is assumed to generate is assumed to be used to generate to produce electricity. And this produced electricity from this saved biofuel is assumed to be replaced in a to replace the one that is produced in a coal-based power plant, which have average EU average. And by doing this, we eliminate CO2 emissions, and we gain benefits when we implement the carbon cost abatement costs. So when we look at the cost effectiveness of these measures, we use the net present value method to estimate the cost of final energy savings. And we developed a ratio of total investment costs, which include material costs, installation, and replacement cost, to the total net present value of saved energy for space heating. And we've seen if these values are less than 1, that means the measure is cost effective. And if they are more than 1, that means they are not cost effective. And we assume the total lifespan of these measures to be 50 years. So if we see the results of the simulation, we can see the initial energy use of the building, where the highest space heating demand occurred in winter months due to the weather conditions in Sweden. Whereas in the summer months, we have approximately very low or no space heating demand. And we can see that when we apply insulation, we can, the higher the insulation, the thickness, the higher the energy savings. And we can see that roof and exterior walls insulation gave approximately similar final energy savings of approximately 17 megawatt hour per year, whereas ground floor insulation gave relatively higher, lower final energy savings. We can see that windows placement, for example, when we put 0.8 windows, we get highest energy saving, approximately 28 megawatt hour per year, whereas doors replacement gave relatively lower. We can see the results of cost effectiveness analysis. If we look at the attic insulation, we can see that the values of ratios are already less than 1 before considering the carbon abatement costs, the benefits. And even after including carbon abatement benefits, the cost effectiveness increased of this of the attic insulation. However, here we can see that we can realize the influence of this carbon abatement benefits more in case of exterior walls insulation, where we can see that before including the carbon abatement costs, the ratios were above 1, which indicates that it was not cost effective. However, after including carbon abatement costs, we can see that we can insulate up to 150 cost effectively for the exterior walls. Similarly, for the ground floor, we can see that before considering carbon abatement benefits, it is not cost effective. It was not cost effective. However, after including the carbon abatement benefits, we can see that it was cost effective to apply 50-100 thickness of insulation to the ground floor. In case of Windows, it was cost effective even before including these carbon abatement benefits, due to, since that Windows gave very high final energy savings. So it was cost effective even before including the carbon abatement cost. And we can see for doors, for example, the influence. Before including the carbon abatement benefits, it was not cost effective to replace doors. However, after including the carbon abatement benefits, we can see that it is cost effective to use 1.2 doors. In conclusion, this study showed how it is important to renovate the existing buildings in Sweden. And we can achieve the final energy savings from 2 to 13% by insulating the building envelope. And we can achieve it 20 to 23% of final energy savings by replacing windows. However, most of these energy efficiency measures were not cost effective. However, after we implement the carbon abatement benefits, most of these energy efficiency measures became cost effective. Hence, this study or the implementation of these carbon abatement benefits encourage further energy efficiency improvements and improve the cost effectiveness of the measure.
It was quite an interesting presentation. I don't see any questions from the audience. I don't have a particular question, but I think that considering CO2 abatement in the cost effectiveness calculation is useful. But isn't in Sweden the case? This is regulated in such a way that you can, based on that, and what are the perspectives?
I did not understand what is your question.
About including the CO2 abatement, that would definitely help the cost effectiveness of the renovation measures.
You mean if it's already considered in the project?
In the Swedish regulation.
It's not included in this context to see whether this will affect the cost effectiveness of measures or not. So usually it's separated.
Okay, but I'm not sure that I know the situation in Sweden regarding the CO2 cost included in the cost of the fuel or cost of the energy.
Yeah, it might be included in the power plants when you generate electricity, but not when renovating buildings. They don't analyze the amount of the reduced CO2 emissions and compare it with or convert it to cost. That's not included in the renovation of buildings.
So where the financial value of the CO2 abatement is derived from?
It's derived. It has a reference. It's derived from the European curve for the average abatement cost for CO2. So.
Okay. So anyone from the speakers, the other panelists have a question for yourself? Well, if not, thank you very much, Yusuf. We will go to the final presentation, which is shared by Marius and Dragos. It's about Smartware, a certified low-energy passive house office building in Romania.
I want to share with you a story of an amazing building and especially the entire experience of designing and constructing it. I am Mario Șoflete and I design, I build, I teach and I preach building construction methods in Romania as a structural engineer, carpenter, passive house specialist, trainer with International Order of the Architects from Romania and video content creator on my YouTube channel. Along with my team from Creative Engineering Office, I had designed the structure of this building, the technical details, and also made the technical management on the website for the project that I will present it to you.
Hello everyone, my name is Dragoș Arnautu, I am an architect, I'm a passivist, and I consulted and certified this project on behalf of the Passive House Institute in Germany. It is a great pleasure to share an example of yes we can, in the shape of a beautiful office building.
21 days for design, 44 days for assembling the CLT structure, 890 structural panels made from CLT, meaning 890 cubic meters of wood, 2.5 trees used for each one of the future 250 users of the building, 2,380 square meters of usable space, less than a year from design and build to its users. It is a national and Eastern European record. This is Smartware Creative's new headquarters, commissioned by Gabriel Ciordaș, certified as PHI Low Energy Building, and currently the biggest CLT construction in Eastern Europe. With a cold climate situated in Eastern Europe and with a population of 20 million people, Romania has a high demand for new buildings, estimated to more than 20,000 new buildings each year. The first mandatory legislation for energy efficiency in buildings was adopted in 2005 as we joined the European Union. The benchmarks were very vaguely defined and the requirements were very basic, as the price of natural gas used as fuel for heating is one of the lowest in Europe. Coupled with a low average income, the incentive to construct energy efficient building was quite small. Because of that, the construction market hardly assimilated the concept of energy performance with a low implementation in the new projects. The first certified passive house was designed and built in 2014, and by 2020, less than 10 buildings were certified in this standard. The Creatopy X Smartware project started at the end of 2018, when Gabriel Ciordaș, the CEO of the IT company from Oradea, Romania, contracted us. The main design team was an office building for 250 new users who should work in a comfortable environment. And all of that had to be done within 1 year because they were in an exponential growth. They had already occupied all the office buildings that could be rented in Oradea, and all the rented spaces had a major comfort problem, which affected their quality of life, furthermore the performance of work. When all of this started, nobody had in mind to have a passive house building. The main emphasis was to ensure that all occupants would have a high quality of comfort and working condition. In February 2019, we had started to work for the preliminary design, and a few months later, in April, we had the final design chosen based on what we've started to do the structural concept in CLT panels. We choose this material because it is a completely prefabricated constructed system and has a highly assembly speed. One of the biggest challenges that we as an engineering office had to overcome was the very tight schedule we had to fit in order to be able to send the order to the factory. So to be able to deliver such an amount of data in such a short time frame, we had to have a complete understanding of the project, and we actually completed the design process by going to the factory that produced the CLT panels so that we will be sure that everything is very clear. In May, the construction of the foundation started, and in August, the assembly of the CLT structure began. The assembly team was made out of a construction engineer, a car mechanic, a jeweler, an electronical engineer, and 2 carpenters. This team managed to assemble the entire structure in less than 44 days. In order to save time, the entire structure remained visible at the inside, and this makes this building the largest one in Europe with fully visible CLT structure. All the building service and interior finishes took about 4 months to be completed, so the building that you are now seeing on the screen went from a concept to being implemented and fully operated in less than 300 days.
The building is developed on 4 platforms. The level differences are a natural response to the slope of the land. This justifies the non-invasive approach that helps animate the building both inside and outside. The main entrance is located on the southern facade, and it leads to a spacious atrium and central lobby. There are 8 open office zones located in the building's northern, eastern and western perimeter. The conference rooms, together with the common areas and toilets, are organized around the central interior garden in order to receive natural light. The previously agreed architectural concept design imposed a series of challenges to achieving the late adopted passive house standard. Besides the generous thermal envelope surface area, the window-to-wall ratios are quite small, resulting in minimized solar gains. Window-to-wall ratio towards the east is 20%, west is 29%, north is 17%, and most importantly, the south window-to-wall ratio is only 10%. The energy balance of the building has been calculated with the use of PHPP, the Passive House Planning Package, and the results are as follows. The heating demand is 27 kilowatt hours per square meter in year. The heating load is 18 watts per square meter. The cooling demand is 18 kilowatt hours per square meter in year, while the cooling load is 15 watts per square meter. The air tightness was measured at 0.3 air changes per hour at an under and over pressure of 50 pascals, which is great, and it is a proof of great workmanship and attention to detail. The primary energy renewable containing the servers lies at around 160 kilowatt hours per square meter in year, while if we were to take out the servers of from inside this building, we would see that the normal operating energy demand, primary energy demand, would lie 100 kilowatt hours per square meter in year, less around 60 kilowatt hours per square meter in year. So the servers are the major energy consumer in our building, and not only the use of the servers, but also the cooling, constant cooling of the server systems. The thermal properties of the envelope are as follows. The U value of the exterior wall is 0.16 watts per square meter in Kelvin. The U value of the roof is roughly 2 times better at 0.09 watts per meter square in Kelvin. The U value of the slab on grade is 0.19 watts per square meter in Kelvin, while the frames have the following properties. The U value is a mediocre one at 1.2 watts per square meter in Kelvin, and the glazing has a U value of 0.61 watts per meter square in Kelvin, while the solar heat gain coefficient lies at 52%. Due to the suboptimal parameters of the windows, heating had to be provided in the direct proximity of the window surfaces in order to counteract any possible discomfort feelings toward the user.
The high execution speed and the short time we had to finish the construction put great pressure on the workers and contractors. To be able to keep such a demanding project with an even more demanding deadline required to the teams to be in sync with each other. Everybody had to have clarity in their task and a verification system in order to avoid mistakes that could cause delay. Because of that, I stepped in as a technical coordinator of the project and made integrated details clear and easy to be understood. For example, the connection detail of the reinforced concrete foundation with the CLT structure, where each step, starting with the sole plate, mounting the CLT structure, the fiber cement boards on the spacers, which ensure the local ventilation of the wooden structure, the waterproofing in 2 layers, the thermal insulation connected without thermal bridges, with all the required accessories, and the sequence of steps we've traced and clearly delimited between the contractors. When the details grow in complexity, we double them with video content distributed to each worker. This way, we had an almost bulletproof system where the space for mistakes was as small as possible. The feedback we received from the workers were very tangible immediately. Almost all the deadlines were met, and there was no significant delay in the building process. Once again, it was proven to us that this method was effective when we did the blower door test, and we recorded a leakage coefficient N50 of 0.28 changes per hour at 50 Pascal, well above the passive house requirements. Even though from the beginning it was not planned to be a certified building, we used the passive house principles when designing it. During the construction process, I've noticed that things were going very well and everybody was paying attention to all the little details. I've rediscussed with the owner the option of certification as a guarantee that all of the comfort requirements of the building are met, something that all of the employees asked for the first place. So this is how actually we've managed finally to certificate this building as a PHI low energy building.
The building services such as the heating, ventilation, air conditioning and domestic hot water systems have a significant impact on large buildings and their energy consumption compared to smaller residential buildings built to the Passive House standards. The high internal loads and the fluctuating load profile of an office building highlight the impact of sensible and latent internal heat gains. The ventilation is done by the 8,500 cubic meter per hour energy recovery ventilation unit, which has an effective heat recovery efficiency of 67% and a humidity recovery of 40%. The air is supplied to the 8 zonal units marked in purple, which in turn provided to the dedicated zones marked in yellow through underfloor air chambers via the local outlet units marked in light blue. Besides post-heating and cooling the supply air, the zonal units are capable of providing additional heating and cooling of the spaces through air recirculation. The post-heating and cooling of the air is done inside the zonal units by water-based coils connected to 4 dedicated air-to-water reversible heat pumps positioned outside the thermal envelope. The zonal units extract the air at the top, also connected with the energy recovery ventilation unit, and supply fresh and reconditioned air at the bottom, under the entire floor area of each specific zone towards the local units. The local units supply air to the rooms from under the raised floor and are able to locally regulate the temperature and airflow according to the loads of each zone and user needs. They are provided with temperature sensors, dampers and centrifugal fans. Local units and zone units are integrated into the building's management system for centralized control and optimized energy consumption. Energy initiatives such as the demand control ventilation, which measures and maintains CO2 readings to an acceptable level, occupancy detection to reduce the unnecessary operation of air conditioning units, night purging and optimal startup have been implemented to decrease HVAC energy consumption based on the building load and usage profile. Parameters such as relative humidity, CO2 and temperature are monitored and used to increase building occupant comfort levels. The hot water demand is satisfied via a decentralized system using 10-liter direct electric boilers for each individual water tap. The server room and additional technical spaces are conditioned by water-based chillers connected to 2 dedicated reversible heat pumps. The installed servers are of the latest generation and among the most energy efficient options on the market today. The PHI low energy building standard is part of the Passive House building criteria and allows twice as much heating demand and a bit less air tightness than the classic Passive House, but is still quite challenging. Nevertheless, it is a beautiful example of yes we can, and being certified as a PHI low energy building, it sets a pretty high bar for the next office buildings in Romania and Eastern Europe. It has been a real pleasure to be part of the team, and with this opportunity I would like to thank everyone involved for making this project happen and for making this project a certified PHI low energy building. A warm thank you to the organizers of this conference, and I am looking forward to our discussion.
The thing that surprised me the most was the dedication of the workers that were asked to deliver the highest quality, and they did that with a lot of passion and joy. From the carpenters that set up the structure to the crane operator that had the precision of a surgeon while handling some of the biggest CLT panels, the waterproofing team that understood the effect of the water on a wood building and made all the effort for that not to be a problem in the future. Or the general contractor who managed to provide all the necessary resources to all teams involved. And last but not least, the craftsmen who spent hundreds of hours in arranging with care all the building services and electrical routes that made the building look like a starship. And something that surprised me and I highly appreciated was the attitude of the owner and the project manager toward the project, who wanted the building of the highest quality with no reduction in cost in order for their employees to work and develop in a healthy, sustainable and comfort environment, even though the building was way over the budget that was initially planned. And with this project being a great success, 2 more buildings will follow for the Create-a-Pit team that will be a point of discussion for the next time when it will be done.
Well, a very dynamic presentation. Thank you both. Yes, we can, and I'm proud to be in the same region with you. There is a challenge. Of course, there is a best practice for new buildings, but we need both for renovation and for new buildings pilot cases, best practices, in order to share and in order to gain confidence, especially for building offices in a country when the tradition is concrete and brick, or the modern buildings are the jar buildings. So yes, maybe wood is something related to taste, but it's one of the possible choices. I will have one question. Maybe it's a technical question, but it was quite a technical presentation. Would a bigger glazed area on the south and less on the east and west could have led to a better energy balance in winter and also in summer?
Yes, the problem was that the southern facade was not quite good orientated with the entire surroundings. So actually the most exposed facade is the western one and the eastern one. The southern facade is quite opaque, so they're quite, I think on the southern facade are only 2 windows as it's exposed to an unwanted part of the site. The most interesting the most interesting view of the site is on west and east, and also within this building there's an interior garden with full of windows that have almost zero natural heat resources. And from the beginning, the passive house standard on this building was not a mandatory need. The most important thing for them was the comfort condition, and the passive house principle weren't applied at the first stage of the design, so that we didn't make any iterations to reconfigure the thermal envelope and the position of the windows, due to the fact that it was on a very fast forward project, and that the final architectural solution was chosen by the owner without having time to make all this optimization or all the iteration. But still, more windows on the southern facade would have been useful to achieve the passive house standard, and also better window frames, because we had problems with the window frames as they were delivered in with lower properties than we required. Even though we've required certified passive house components, they delivered us so they delivered to the project with lower characteristics. Not that good as we wanted.
If possible, I might just add that I think Horia was onto something here when he asked, okay, would this actually help? Because we also have a cooling demand in our building. So the question is, where do you draw the line between heating and cooling a building? I would say that a couple of more solar radiations from the south would have been helpful to decrease the heating demand during winter, and we could still afford a higher cooling demand because we can always properly shade those windows and they cannot affect us in such a way. So I do believe also with regards to the availability of the energy, we can cool the primary energy factor for cooling should be a lot less, because during summertime we do have a lot of solar radiation available and we could generate it on site. In comparison to winter, when we need to look at stored energy to invest and to consume in our building. So this is where I could see some potential for improvement. But as Marius stated, some of the decisions were already met when the design decisions when we thought about certifying and going passive.
Yeah,
I have one question, if I may.
please.
Unfortunately, I didn't see the whole presentation because I had a technician coming in for the internet connection. But what is the window area, the glazed area in the building? That is one question. And another question, or that is maybe a comment. Yesterday we had a good presentation where somebody showed that if we make a strategy for the ventilation of buildings, if we use shading and natural ventilation, we can cool the buildings as probably as with mechanical ventilation or technical ventilation. The first question was the sizes of the glazed area, and the second question is around this. Have you had any thoughts about using natural solutions to cool the building during the summertime?
Sure. So the window to wall ratios are quite pessimistic, I would say. In a normal environment, they would be roughly 30%, but or up to 50%. Even more in office buildings, which tend to be fully glazed and completely non-energy efficient. But in this case, it would have been helpful at least to an extent of 30%, 40% glazed surface. This would have been helpful. Combining that with better windows and some shading elements, the result would have been better. So to answer your questions, they are under 30% window to wall ratios on all of this facade. The southern has 10 actually. And the other question was related to natural passive cooling systems. The building has a BMS, a building management system, that is able to actually sustain an intricate program, daily program, 1 hour before the start of the office times. It does a purging, so trying to completely change, do one air change per hour of the building. During the night, especially in summer, some windows of the interior garden are opened in order to allow for natural ventilation and natural cooling, of course. And also purging takes place at the end of the working day in order to cool again the environment.
Thanks.
Thank you. Thank you very much. We have only 1 minute to close the session, not before to mention a tricky question from Eddie and Joyce that already have been answered in Zoom. So Adrian, please check in Zoom. It was about if you know how much carbon is captured by the wooden structure, is that a good method for carbon sequestration? Adrian, if you need more information, please join a conversation with Marius on that, because he will give you all the details. Thank you very much to all panelists. I just want to make 2 announcements. One is that we meet at the same time tomorrow for the next session, the 4th session of panel 8, which is methodologies for better decision and quality towards carbon neutrality in buildings. The last presentation was also highlighting the minimizing the gap between what is designed and what is realized by a very good quality. And the last announce about the informal session for this afternoon, they will start in 15 minutes. Session, first one, showcasing the ABC21 project, which is looking at the African and European bioclimatic designs and the use of local materials as methods to develop and promote sustainable buildings. And the second one, it's an informal meeting to meet and chat with the other delegates over a beer or coffee or whatever you like to discuss. Both sessions are in Zoom in meeting mode, so you can switch cameras and get involved. So thank you very much and hope to see you tomorrow.